let's take a look at how to predict whether a substance will dissolve in water or not. We're going to take a look at applying solubility rules. Now, this set of solubility rules that we're going to be looking at applies to ionic compounds. Let's say I need to get a type of silver that I can put on paper and produce an image. That's how photography works. But I need a silver ion that will dissolve in water. Which one of these substances will dissolve in water? I could take them and put them in water and test, but it would be good to be able to predict which one would work without spending the considerable amount of money involved in purchasing all of these different types of silver. And it just happens that we have a set of guidelines that help us determine or predict if a substance will be soluble in water. You'll notice that the first group of ions that we're going to talk about are ones that are mostly soluble in water. And as we progress to the bottom part of our sheet of solubility rules, we're going to start seeing ions that indicate the substance will not be soluble in water. It will be insoluble. Let's take a moment to look at these rules one at a time. The first rule deals with nitrates. And our generalized rule is if we see a compound with NO3, it is going to be soluble in water. That means silver nitrate will be soluble in water. What about other compounds that end in nitrate? If it ends in nitrate, if it contains NO3, it is going to be soluble in water. The next rule down on your list looks at acetates, and it says all acetates are soluble except silver acetate. Now we have to start keeping track of a few exceptions. What about calcium acetate? Yes, if it has the acetate ion in it, it is going to be water soluble. And the next rule is looking at chlorates. And once again, if it ends in ClO3, it is a chlorate, and it's going to be soluble in water. So here we're looking at a compound, and we see that it has ClO3 in the compound, the negative ion. The anion is ClO3. So this compound is going to dissolve in water. We're pretty confident of that. And as we move on to the next rule is helps us predict how compounds that end in chloride are going to dissolve in water or not. And the rule says that all chlorides are soluble except, and then we see here a bunch of exceptions. Now, you may not have to memorize those because you may get to use this set of rules on your test. So if you don't have to memorize those, that's going to be a real help to you. So if you see a compound where the anion is chloride, you're going to have to take a look to see what is the cation. I look here and see lead chloride, and I remember all chlorides are soluble except, and I look up here and see lead chloride. So this is going to not be soluble in water. But if I look at iron chloride, well, iron is not on my list of exceptions here, so iron chloride is going to be soluble in water. So as we continue here with the things that are mostly soluble, we see all chlorides are soluble except, And we see all bromides are soluble except, and all iodides are soluble except. And so if we have these lists of exceptions to the rule, it becomes quite easy to look at a compound and determine, is it soluble or is it not soluble? And then the next rule, the next solubility rule on your list, deals with sulfates. SO4 2- anion. And it says all sulfates are soluble except, and then we have a fairly long list of exceptions. So barium sulfate, lead sulfate, mercury sulfate, calcium sulfate, and silver sulfate are not soluble. So for this next rule, we're going to be looking at not the anion, but the cation. So we're going to move to looking at the positive ion. And it says that if the compound starts with an alkali metals, those are things in group 1A. And remember, those are things like sodium, potassium, and of course these are the cations. Sodium, potassium, lithium. I'm not doing these in any particular order, but those cations, any of those will be soluble in water if it starts with a group 1 cation or NH4 plus 1. Those things are all soluble in water. So for the last few minutes, we were looking at anions and cations that helped us predict that these things would probably dissolve in water. The lower part of the solubility rules guidelines tell us the things that are probably not going to dissolve in water. And the first one of those is if it has a carbonate, CO3, it is not going to dissolve in water unless we combine it with something from group 1 or NH4. So here we see two compounds. The iron 2 carbonate will not dissolve in water because it ends in carbonate. But the ammonium carbonate will dissolve in water because of this little exception right here to this rule. All chromates are insoluble. So if it ends in CrO4, that ion, it will not be soluble unless the cation is a group 1 metal or ammonium or calcium or strontium. And moving down the list, hydroxides in general don't dissolve at all, but if it starts with an alkali metal, oops, we need to do that in green. If it starts with an alkali metal or ammonium, it will dissolve in water. Or if it's barium, strontium, or calcium hydroxide, it'll dissolve a little bit. Now, as far as phosphates and sulfites and sulfides, phosphates are insoluble, sulfites are insoluble, and sulfides are insoluble unless it's combined with an alkali metal from group 1 or an ammonium salt. Of course, we see here that for sulfides, that exception also includes group 2 elements. So let's just look at some compounds and see if we can predict whether it will be soluble or not. And I'm going to pause and give you some time to think about these. And we're going to start with number 1, ammonium acetate. And we're going to think, is it soluble? And what rule helps us determine if it is soluble? What did you decide? Well, you probably decided that since this compound started with ammonia, it will dissolve in water. Of course, the rule about acetates also tells us that this is probably going to be water soluble. What about barium hydroxide? Soluble or not? Well, we have a rule that says hydroxides do not dissolve, but barium hydroxide actually dissolves a little bit. So it is soluble. So we'll put a green box around the things that are water soluble. What about iron carbonate? Iron carbonate falls under the rule governed by carbonates. And it says carbonates don't dissolve in water unless you have a carbonate that starts with an alkali metal or ammonium salt. Now what about NaOH, sodium hydroxide? We have a rule that says hydroxides don't usually dissolve in water, but we also have a compound that starts here with an alkali metal, and that changes everything. So yes, this is soluble because it starts with a group 1 metal. Rubidium nitrate, the next on our list, number 5. Rubidium is an alkali metal, and we have a rule for nitrates that says they are soluble. Easy compound to determine. It is soluble. Cesium sulfate. We have a rule that says sulfates are generally soluble. Oops, green. And also this starts with an alkali metal, so it's definitely soluble. What about magnesium sulfate? Magnesium sulfate. It's good to go back and look at the rule for sulfate. And you'll see, if you do that, that sulfates are mostly soluble. And chlorides are mostly soluble, so zinc chloride is going to be soluble. So take a look at these 4 compounds and decide if they're soluble or not. You may want to pause the video at this point so you have time to look at those. Phosphates are insoluble unless they are with a group 1 cation, so not soluble. Bromides are soluble, except in this case, silver bromide is one of those exceptions on the list that says, nope, not going to be soluble. Nitrates are generally soluble, and if it starts with an alkali metal, it's definitely going to be soluble, so 2 rules tell us that this is soluble. And sulfides are generally not soluble. So there you go. We are ready now to use this information to help us do one more type of problem.